Dear student, I am Dr. Harold Thomas, Professor in Applied Geology, Dr. Hari Singh Gaur Vishwavidyalaya Sagar. Today, I will deliver my talk on mineralogy. In this topic, I will cover about the classification of minerals, cation-based group, anion-based group, physical property of minerals, for example, crystal form, cleavage, color, streak, luster, play of color, fracture, hardness, density, and magnetic properties of minerals. The megascopic identification of rocks forming and ore forming minerals, crystal system, chemical composition, physical properties, and diagnostic features. Besides the physical properties, occurrences, uses, and more importantly, their Indian occurrences. For each minerals, in order to deal systematically with minerals, it is necessary to have some methods of classification. Minerals may be classified in several ways, nearly all of which are dependent either upon their chemical composition or on physical criteria. First, based on cation present in the minerals. Second, based upon anionic groups present in the minerals. Cation based group. It is a combined economic and chemical classification in order to fulfill the needs of the beginners in economic geology. This is in effect a group of ores of each elements. For example, iron minerals, hematite and magnetites are grouped under ores of iron. H.S. Reid in his book Rutley Element of Mineralogy 1929 grouped the minerals based on a periodic classification of elements. Minerals groups according to periodic classification of elements. Group 1A, lithium, sodium, potassium, copper, silver and gold. Group BA, beryllium, magnesium, calcium, strontium, barium. And group B, zinc, cadmium, mercury. Group 3A, boron, aluminium. And group 4th A, carbon, silicon, tin, lead. And B, titanium, zirconium. Group 4A, phosphorus, arsenic, antimony. And 5th B is bismuth, vanadium and tantalum. Group 6A, chromium, molybdenum, tungsten, and B is your sulfur. Group 7A, magnesium, 7B, fluorine, chlorine, bromine, iodine. Group 8, iron, cobalt, nickel, and group 8B, ruthenium, rhodium, and palladium, osmium, iridium, and platinum. Anion based groups. This system classifies the mineral species into major division or classes according to the nature of the anionic groups present. For example, oxide, halides, sulfides, and silicates, etc. The broadest division of this mineral classification is that used by Dana 1944-62, Berry and Mason 1959, and Deer, Hove and Jussman 1962. The classes are as follows. First, native elements. This includes metals and non-metals. Metals, gold, silver, copper, non-metals, arsenic, bismuth, sulfur, carbon, etc. Group second is your sulfides, galena, PbS, sphalerite, ZnS, chalcopyrite, Cu2s, and chalcocite is Cu2s, and chalcopyrite is CuFeS2. Third, oxides and hydroxides, chromite, FeCr2O4, pyrolusite, MnO2, piezomelane, MnO2S2O, hematite, Fe2O3, bauxite, Al2O3S2O, halides, NaCl, fluorides, CaF2, carbonates, calcite, CaCO3, magnesite, MgCO3, nitrates, niter, KNO3, sulfates, gypsum, CaSO4, 2S2O, phosphate, apatite, Ca5PO4 thrice, fluorine, chlorine, OH, tungstate, wolframite, apatite, Ca5PO4 thrice, Fe, chlorine, hydroxyl, OH, tungstate, wolframites, FeMnWO4, silicates. These are characterized by the silica tetrahedral structure. For example, quartz SiO2, potash feldspar KAlSi3O8, albite NaAlSi3O8, mica KAl2 AlSi3O10 OS twice, pyroxenes FeMg twice, Si2O6, amphiboles Ca2 MgFe5 Si8O22 OS twice. It can be seen that this classification originally based on the chemical principles that has definite significance in terms of crystal structure. Every mineral has a characteristic crystal form, and on the basis of form it can be identified. Few minerals have distinctive growth habits elongated in a direction. Some minerals show characteristic form, for example, columnar form, large crystals with equidimensional cross section. Example is tourmaline, bladed form, flattened, kyanite, stibnite, acicular, needle-like, natrolites, fibrous, fiber, asbestos, gypsum, radiated, diverging from common center, anthophyllite, short, extended along A and B axis. Twinning also becomes diagnostic. For example, penetration twins of fluorite is cruciform or diagonal twin of stellite, cleavage or lamellis. Minerals usually split along definite planes is called cleavage. It can be perfect, imperfect or absent. Halite, cubic cleavage, fluorite, octahedral cleavage. Some minerals break in preferred direction along bright planar surfaces. The cleavage, the minerals having the cleavage is called foliated. For example, mica, most often the foliation is a basal cleavage and is called lamelli. Color, it is not diagnostic and rarely constant as in azurite, which is always blue. Color is mainly based on chemical composition. A trace amount of impurities can give rise to definite color to the same minerals. Quartz occur in various colors and hence does not have any diagnostic color. Streak, it is the color of powder of a mineral. The streak gives color effect because grain size effect is reduced. For example, hematite black and give cherry red streak. Luster, appearance of the surface in reflected light is known as luster. It can be metallic or non-metallic. The non-metallic luster is divided in vitreous like glass, resinous like resin, pearly like pearls, silky like silk, adamantine like gemstone, and greasy like oil. It can be glittering, dull and glistering. Tarnish, thin surface film formed due to exposure, bornite sour tarnish, play of colors, labradorite, variation of colors observed from different angles, fractures. All surface of broken other than cleavage surfaces are included in this category. For example, conchoidal is smoothly curving fracture surface as in glass, splintery, fibrous, even, nearly flat fractures, uneven, rough and irregular fractures as in rhodonite. Tensity, resistance offered by a mineral to breaking, crushing or cutting is called as tenacity. It is also as brittle, flexible and clastic. Malleable, change of shape when hammered without breaking, it called malleable. Hardness, hardness is relative resistance of a mineral to scratches on the surface. It is a distinct property of a mineral as it is governed by a crystal structures and bounding forces of atoms or molecules of the crystal. A scale called Mohs relative hardness scale after Mohs, an Austrian mineralogist who developed it in 1825, and each marked by a common minerals. Mohs scales minerals hardness of some familiar objects. 8 hardness topaz, 9 hardness corundum and 10 hardness is diamond. Density and specific gravity. Density is the mass per unit volume. It means every substance when cut into a cube of 1 centimeter, its weights will be its density. One can assess relative density by starting light, medium, heavy or very heavy. If we measure the ratio of the weight of a substance to the weight of an equal volume of pure water, it is the specific gravity and hence no unit, being the ratio of 2 weight. Magnetic properties. Some minerals are attracted to a bar magnet. This magnetic properties is attributed to specific properties due to spin of an unpaired electron of atoms and molecules. In mineralogy topic, I have covered the classification of minerals, cation based groups, anion based group, physical properties of minerals, for example, crystal forms, cleavage, color, streak, luster, play of colors, fractures, hardness, density and magnetic properties of minerals. For further studies, please read the books and references given in the text. Thank you very much.